Welcome to a new episode from Energy Bridge. Today we have the pleasure to have Professor Hubert Fechner. He's 30 years experienced solar engineer, pioneer also here in Austria, and policy architect. So you have been advisor for many countries, being part of interesting projects. So we are very happy to have you here. Thank you for accepting the invitation.
We have the entire page written about what you have done. Mm-hmm. I'm sure that Daniel was not able to mention everything, but we would like you to mention a couple of the big major things that you have done all through in 30 years of your experience.
Okay. Yeah, so you were our professor in the master program at the TEB, and it was very insightful to hear from you your all experience about the industry and how it has evolved. So, but what we didn't know from the lectures, it was your own experience and career path. So we know that you studied electrical engineering. So how was that period, and how did you get from electrical engineering to the energy sector?
Yeah, that's basically quite a funny story, because I was studying electrical engineering with a focus on energy from the very beginning at the Technical University of Vienna. Mm-hmm. And of course, when you go into more detail of the future of energy supply, and there were a lot of lectures about what the people think that the future of energy might look like. And this was it's a long time ago, it was in the mid-80s of last century. Mm-hmm. And of course at that time renewable was really nowhere. So there was no use of renewable, except of course hydropower, specifically in Austria, has a big role already there. But altogether, for example, solar energy was really nowhere at the beginning, and also bioenergy and all the other things are really less than 1%, or not even on the market at all. And at that time, of course, we were very much discussing about the future of energy supply, and we saw, and we also heard from our professors that fossil energy might have some limitations concerning basically availability of resources. Mm-hmm. But more and more, it was also at that time already clear that it's an issue of climate, that we cannot afford really to put more and more of this carbon dioxide in the atmosphere. And so for me, it was quite clear, okay, this is not the future. And the other option which was offered also at that time was nuclear energy, which of course was at the time, late 60s, when Chernobyl happened. And at that time, it was very clear for me that, okay, we have to look for alternatives. And during that time, they were really mentioned to be just alternatives. Meanwhile, it has changed, so they are just about to become the main sources of energy. And this is really a period which I was able to join through more than 30 years now, when I saw really this transition from the very first beginning to a status where, okay, we are by far not at the end, but at least a lot has meanwhile happened. And when you see, we have at least in Austria now clear, nearly 95% of our electricity coming from renewables, and in other European and outer European countries as well, that renewables are really taking over. This is really very nice to see all throughout these 3 decades what has happened, what are the obstacles, what were all the barriers which were on this way. And of course we have a lot of other barriers in front of us, but nevertheless I think renewables is the only solution to care for a sustainable future of the energy.
Oh, yeah, that's amazing. That's why we are here, and this is what is joining us in this journey. So, so you started the industry from the really beginning. So when you saw these first prices with PV at the beginning, which very expensive, could you envision that this technology was going to be as it is now, or?
I think nobody really could envision this in detail, how it might be possible to do it. to come to such a mainstream technology like PV is right now. Because of course we were starting at the beginning to saying the cost of 1 kilowatt hour of photovoltaic is corresponding to 14 shilling. This is more or less €1 for the moment. And everybody told, okay, yes, it might be a niche technology, it comes from space, and maybe for very remote places this might be a solution, but there is no energy economic relevance in this technology. I was convinced from the first moment that this might not be the answer, because I think we have to ask the question, where are really the technology limitations of this technology? Is it the basic resources, which is silicon? Silicon is not really a big barrier because it's available everywhere. And all the other components, they are not per se limiting the far spread of photovoltaic technology. And then if you only refer to cost, you should not do that in the very beginning of a technology, because as long as there is no market and no economies of scale, of course, every start is expensive somehow and not comparable to other technologies. And of course, then it took quite a long time when PV really made it to the market, mainly supported by a few, it's just a handful of countries at the beginning, who supported PV markets very much, despite there was really high prices and not comparable prices.
Like some support.
Yeah, all this feed-in tariffs and other support schemes, and there was to mention mainly Germany. They did a lot in the beginning. Of course, Japan and other countries really supported the technology, which was very expensive in the beginning. But they also believed that yes, there is a future of these technologies, and we really should be somehow thankful to these politicians who really urged and really brought this development forward, supporting a technology only because it seems to have a bright future, and this finally turned out to be true.
Yeah, and do you think that we are facing some similar situation with hydrogen?
With hydrogen, I won't give my personal evaluation on hydrogen, but I only can tell you hydrogen has meanwhile faced a lot of ups and downs in the history. So I remember I made my own, it was a small exposition for hydrogen in 1985 or 6 or something like that, when hydrogen popped up for the first time as really, let's say, a very important energy carrier for the future. And there were some hypes in between, and now there seems another hype to be with the big amounts of wind and solar we have right now, in order to have an adequate storage media. But nevertheless, hydrogen for sure has a bright future. But of course, what we ever have to think about is that there's a topic of efficiency behind. And that's why there is a future of hydrogen. But maybe it might look different that some of the experts have seen 10 years ago.
And Professor, we were looking at all the work that you have done. It really intersects engineering that you studied at Technical University of Vienna. You have been giving a lot of policy advisory to multiple stakeholders, and you are also very much active in the education domain, being professor at Technical University. How do you see impacting your own career, and also advancing solar energy, all the collaboration that you saw coming along and the experience that you had?
Now, I think doing business in the renewable field is not really a job. It's really something which, let's say, has the potential really to move something. And when I think back at the first moment, I saw, okay, it's not just about technology. It's really about a lot of other factors as well. It's technology, it's policy, it's social issues, it's all the behavior of the society, it's infrastructure and so on. So really a lot of factors are coming together. And so even though I'm a technician from my education, I thought that the technology on its own is not sufficient to bring forward these technologies. You also have to open your eyes and have a look on other fields where there might be an impact on the further deployment of photovoltaic, solar thermal energy, biomass energy, and so on and so on. That means the whole bunch of renewable technologies. And I think this is crucial, and this is of course also very nice to have this broad picture and also to see that individual necessities have to be done in order to bring forward the whole process.
Yeah, and well, you have seen this whole process being also an active architect of it. I mean, being Austrian advisor to develop all this technology. What would you say that you feel most proud about in which goals you achieved?
I don't know if I can say I'm proud of something. What was quite successful, I think, was the collaboration with a lot of other people who have the same idea and were in the same way convinced that this is the right way. And that's why, of course, the most important thing besides the scientific knowledge is, of course, really to keep people informed about what are the needs, why this way forward towards renewable is a reasonable one and is really the best solution for the future. And so I think really education of many people in many different sectors is of course crucial. And also what you also have to think about is always that you, with renewables, you more or less you replace another system which was existing and is existing and is performing quite well, but of course has some environmental disadvantages and so on, and other disadvantages. So you compete with an existing system which is performing quite well, and of course you have also a lot of stakeholders involved in this old business, and so you also have to face and really to try to act in the way to really point out what are the barriers, where are the barriers coming from, because some people in this process of energy transition might also lose. Of course, old technologies are disappearing, new technologies are coming up, and so this is a process which has so many impacts on so many stages. So it's really a very complex situation altogether.
Yeah. Now that you mentioned the social impact, I remember Professor Haas told us about some kind of public polls to ask the society what they felt about the new technologies coming. That was part of a public policy, or it was more from the industry, or it was...
Yeah, policy typically follows what's going on in the society. In many cases, it's not always good, but that's the case, what we are facing in the last decades at least. So it's really about the opinion leaders to come up with clear and fact-based opinions and try to transport these towards the government, towards the population, towards the media, for example, which have also a crucial role in this process. So it's really a situation where a lot of players have to work together in order to change the general behavior, the general moods towards renewables, to point out what are the advantages of a transition. Of course, what are the challenges? It's also very important and crucial to talk also about the challenges, because it's not an easy way forward. We see it through the last decades that we have to overcome a lot of barriers, and this can only be overcome in the way that we see a nice picture of the future in front of us. Where will all that lead to? That's important, that the people really see an attractive future. And only if you know why are you doing this, because you want to achieve another status, you want to achieve a status where we really operate our society without damaging the environment in the way we did in the last decades by using coal and oil and all that.
Yeah, exactly.
And really this attractive picture of the future, this is very crucial in order to convince people, yes, please, I would like to join you on this way forward.
And if you could explain typical value chain of PV for a household, or for a household and for utility scale, who are the players involved? How does the entire process work? if someone has to put across a utility scale PV project, and also for the household?
Yeah, talking about photovoltaic in specifics and the value chain, it has changed a lot in the last years, because let's say 10-15 years ago, the highest value of a photovoltaic system was the PV module by far. So it was up to 70% of the total cost of a PV system was the module. This has meanwhile changed dramatically because of the quite cheap module which are around, mainly because of China stepped into this industry, let's say from 2010 on, and really made the modules manufacture on big scale, and by that reducing the price of the module significantly. And now we don't talk even more about 70-80% of the total cost, but we talk about, let's say, depending on the system, 20-25% of the total cost. So you see, the value lays no more predominantly in the module, just maybe 20%. Then you have inverter cost, which a little less. Then you might have a lot of local value in any way, because of design of the system, installation, maintenance, and all that, which is typically done locally. And all together with subconstruction and so on. So you, in any way, you might have a local value of a PV system in the range of, let's say, between 60 and 80%. And if you really, for example, because we in different parts of the world, we also try to bring up own production, or at least to boost this a little bit. Of course, it would be nice to increase that local value even more, and by that avoiding transport and other costs and so on. But typically the value is about, the local value is in the range of 70% or something like that.
Okay, and do you know some PV manufacturers in Europe at the moment?
Yeah, of course, there exist still some PV manufacturers in Europe. Even so, you for sure know that the PV industry went down significantly, dramatically, let's say, in the last years, because of the very cheap manufacturing in China. And it's not only the module, it's also, of course, the inverter. But still there exists some PV producers in Europe, module producers, cell producers only very, very little. And I think in Europe for the moment we nearly have no production of wafers. That means from the pre-product of a solar cell, this comes more or less 98-99% from China. But then the next step, the cell production, there are very few in Europe, and then module production are even a little bit more. And of course there are a lot of ambitions to bring up PV industry in Europe again, and the same happens to India, where there's a lot going on in incentivizing and bringing up PV industry, and the same is going on in Turkey, for example, the same is going on in the US and so on. So we see now, and this is, I think, very important, and also brings me to the fact of energy and technology security and sovereignty, that we should not rely on just one country. I think this is not a good approach for any technology to be reliable more or less 100% from one country. And that's why this diversification is really very important, not from European perspective only, but also from other perspectives, and that's why other countries really also try to bring up a PV industry.
And Hubert, just one more time, if we can just take a back step. You said with wafer, most of the production is happening in China. When it comes to cell production, some is also happening in Europe. And so you have EPC people who are putting across all the utility scale PV plants. So who are the players involved from? So if you can also tell about that. So from the government, from grid operators, and where do they buy from, and what kind of permits they require?
For utility scale PV?
Yeah.
Okay. Yeah, for utility scale PV, which is now more and more a common business, of course, this really is just about to, let's say, to be added to the conventional electricity supply in high shares. because we are talking meanwhile about hundreds of gigawatt of capacity, which, for example, in Europe we have about 340 gigawatt of installed PV capacity, and this is, let's say, much more than the capacities of other technologies. That means in many countries the capacity of PV which is installed surpasses capacities of hydropower, coal, gas, or something like that. So really, from the capacity, it's really a huge part. Of course, the characteristics of photovoltaic with typically 1,000, 1,500 full load hours cannot be compared to full load hours of hydro technology or something like that. But nevertheless, of course, it changes completely the picture. And it means that the whole energy sector is influenced by that very much. And this starts from the transmission grid operator to the distribution grid operators, to all energy providers. Meanwhile, they offer specific products out of renewables or specific PV products or something like that. And of course, this influences a lot the whole regulation, for example. Regulatory authorities in all the countries, they have to take into account what is now the difference, because we have so many production coming out of photovoltaic, and quite similar, even so happening mainly on the transmission or on the higher voltage levels, is the wind technology. Both technology have a characteristics which are quite different to the old technologies like gas, oil, or coal, because of their intermittency. And that's why we have to really reshape the system completely. We have to focus very much on flexibilities. And of course, we don't see only a change in the generation side, we also see a huge change in the consumer side meanwhile. Because also the behavior of the people and the appliances they are using is completely different than 10 years before.
Yeah.
So we talk about, of course, electric vehicles. We talk about heat pumps, which changing the heating sector quite a lot. We are talking also mainly about the total shift towards electricity. So electricity, which typically has only 20% of the energy share for the moment, might increase to 50% or even more. That means 50% of the total energy in a country goes something about the way of electricity. And so electricity and electrical engineering is really a job of the future, because everything might, or many things might become electrified. And this is of course also which is a dramatical change, which has a lot of implications. And to see that going on, of course, we see also this factor of decentralization, because in former times the people didn't care too much about energy, but now, for example, they were just consumers, and now it's changing. For example, we have in Austria, meanwhile, more than 500,000 photovoltaic systems at a population of 9 million. That means, let's say, in a household of 3 persons, that means much more than 1 million have their supply meanwhile by PV. Yes. And there you see nearly everybody more and more is somehow, has somehow to do with photovoltaics, some with wind, and by that of course also trying to think about electricity, about the behavior, and also about the characteristics of this technology and how to adapt. Why not adapting my behavior a little bit towards the availability of energy? Of course, not doing individually, it must be automated by energy management systems or something like that, but really taking the decision that I will introduce a management system which takes care that my electricity use is highest in the time when there is much availability of solar, wind, or something like that. This is reflected anyway by the energy prices, so it's also a benefit of the people to act like that. So market is very crucial for that, but of course I have once to take the decision that I introduce in my home, in my commercial business, something wherever I'm active, I have to take the decision once to invest in an energy management system which takes into account and operates in the way really to react on the signals of the market.
Yeah, and well, in that point we start with the need of storage, for sure, right? So, but coming back just a bit into the solar industry, which you are expert about, how do you see the new technologies are coming? The perovskite, the agrovoltaics, or all the innovation in terms of technology and installation? The railway that it was this week, that people putting solar panels in railways.
I think we have first to differentiate a little bit between really new technology approaches and applications. Because technology we see, and if you follow the PV technology in the last 10-15 years, you really see a quite, you can tell it slow, advance of the efficiency. So typically 0.5% is the annual increase of the efficiency of a photovoltaic module, which is not that bad. That means in 10 years you have 5% better modules, and this is what we can expect also in future. Because we see, and my personal feeling is that this development might accelerate a little bit even in the future, because now there is much more big business behind. Because 10 years before, PV was a niche technology and only little research were going towards this technology. Now it's really a big business, and everybody wants to have PV and wants to have the best performing PV and so on. And we see also in front of us some new steps of technology which are not really on the market, like the perovskite, all these double layer technologies and so on. So this is not far away from market. I wouldn't say it might come up in the next 2 years, but maybe 5 to 10 years. We might have on the market really PV modules which surpass 30% of efficiency. And when I look back about 10 years, then we were talking about 15%. Exactly. So really this is twice the efficiency. That means you only need half the area to produce the same amount of energy. And this is just in terms of technology development, where a lot of things will come up in the future. And the other thing is, of course, the applications. And this is really where I see a huge of possibilities. What really is somehow established, but not very much on the market, is the building integrated part of photovoltaic. That means to have PV really replacing some elements of the building skin. Yeah, this is the purpose of building integrated PV, really not to be added to the building, but really to replace some parts of the building, like the facade or the roof. The roof is a PV panel, and of course is weather protection in the same way, then producing electricity. Or it is the facade, or it's in future also it might be the window, where you can look out, but nevertheless it's producing energy somehow. And so this is really one part where I see a big future for photovoltaic as integral part of a building, really replacing a building element. There is a lot going on. Of course, you cannot compare it also from the cost with standard PV, which is on open ground. But on the other hand, this is really what a lot of acceptance is there for integrated into a building, because it's nice to look, it's aesthetic, and it does not need another space. So it's really used on infrastructure which is already there. And what we see, this is just the building part. We see PV now integrated also in the mobility sector quite a lot by these sound barriers and by these parking slots which are covered with PV modules. So again, trying to use already existing built infrastructure a second time by electricity production. And this is just where we already stepped in quite a lot, and others are very at the beginning, like the agri-photovoltaic, really to have the approach to come together with the agricultural sector, to convince the agriculture colleagues really to work side by side with photovoltaic, in the best case also bringing up synergies. It's not that they can just install PV and are not too much bothered by these PV modules. No, it's the other way around. PV modules have really a positive effect on their production. What is, for example, for the moment already quite sure, it came out of a lot of scientific research, that especially covering apple plants, for example, apple plants or a lot of raspberries and so on, they really show a positive aspect if they are covered by PV modules. But for others, it's not so clear because it's very different from place to place, from year to year and so on. But really, we are just about to find out where the synergy with the agricultural sector is really given. And then it's a benefit for both sides, for the energy sector and for the agriculture sector. And that's why we also try to find out where is the synergy given. In the mobility sector, okay, we also have sound barriers, which also a synergy. Carports, where there's shade or protection from rain on a parking place. So really there are synergies. And this is where we really have to move on. We really have to say PV really providing synergy, providing benefits for other sectors. And the agriculture sector might not be the least one. Maybe they have any other sectors which might step in later on. We talk about urban PV, really to make the cities more nice to stay in, especially when it's very hot, to have shading, to create places in the urban center with a lot of photovoltaics and so on. And really try to find out where PV really provides a benefit to a specific sector. And there we are at the very beginning, because this door was opened only when the PV models came down in price that significantly. Before it was much too costly for everything, but now, since the modules are so cheap, this opens the door. And for us as a PV researcher, we really have to learn to talk the language of the other sector, because the building sector has a different understanding. They have their own language, let's say, and we have really to learn what is important for them. How do they see photovoltaic? They don't care about electrons and power and voltage. They care about statics, they care about fire protection and so on. And the same is in the agriculture sector. They don't care about power and energy. They care about their crops and all their fruits and whatever, and how are they affected by PV, positively or negatively. And we have to learn to understand the other sectors. And that's we need a lot of, I always call this the interface knowledge, developing further from a pure PV specialist towards a specialist who really understands the language of the other sector.
Hubert, on that note, just we talk about a lot about the innovation that is going on in PV, the application. What are the constraints? You already touched upon knowing the language of the other sectors, but what other constraints are in the application of PV on a scale that we need?
I think most constraint or most barrier is, of course, the knowledge about the technology, because in many large projects, a lot is coming up against some effects PV might have during the lifetime or afterwards or something like that. And this is just, we have to really do a lot of education to the people based on facts, on scientific facts, telling them what's going on during the lifetime of a PV system. What's about the lead in the modules? What's about the change of the energy behavior of this area after installing so many fields, and other effects which might be in discussion, that they might negatively affect the population around or something like that. And of course, we also have, from the scientific point of view, we have to be very much fact-based and really rely on studies, on good studies. On the other side, I think we also have to say very clearly that every technology has an impact. And it is also clear that PV, wind and all the others, they have an impact on the environment. Yeah. And you have energy which you use, you have materials which you use, you have the need to really think about end of life and all that. So I think we should never forget that it's very crucial from the very beginning to try to think, is there a possibility to save energy and not to install any technology. Yes? Not saying that shouldn't go forward with PV and other technologies, but really the energy, the kilowatt hour which you are not using, also has big benefits. So also think a lot about energy saving, energy efficiency and so on, this as the first. And when you use energy, then go towards the best use from the renewable sector.
Yeah, and in that note, have you seen something about PV recycling in some research?
Yeah, sure. We also have a lot of activities in Austria and in Europe, and also in the International Energy Agency. We have our own task dealing with recycling of photovoltaic. And I think, to say it in short words, recycling is a topic in the PV sector which came up in larger volume only a few years ago. Why? Because up to, let's say, 2015, the PV sector was mainly fully concentrated on coming to the markets to become cheaper, that it's really a reliable energy product. Now we have achieved this step, and now, of course, we have huge shares of photovoltaic already installed all around the world, and now we have more and more to think about recycling. And everybody knows recycling starts at the design of a product. Yeah, so the design process is crucial for a later recycle process. And that's why I would say only in the last 5, 6, 7 years, some companies really tried to focus more on the recycling issue, which starts, as I said, on the design, because only if you can dismantle the module after the lifetime in a very good way, then you have a possibility to make a good recycling process. Otherwise, you might just shredder the module as a whole and try to bring out the different materials like you do with a lot of other equipment. But really, recycling in the best way should really go towards a circular economy. That means the best way would be after the lifetime, after some cleaning process or something, out of a PV module, you produce again a PV module. This would be the ideal process. I think we are far away from that, but this is what we should have in mind, really to talk about circular economy in the way that we, out of an old module, we produce a new one.
Yeah, just the good news is that we made a study in Chile. The Ministry of Energy made a research, and the numbers were very promising because it's mainly, I mean, the solar panel is almost full glass, so that's very recyclable. Then it's aluminium, then it's a bit of plastic. So it's just with mechanical desampling, you can, I don't remember the exact number, but it was near to 90% of recycling.
Yeah, of the 90% of the weight or 90% of the volume of the
weight.
Okay, of the weight. Yeah, the weight is very much defined by the glass.
Yeah, and the other materials are very too expensive to recover, silver or other.
Yeah, this is also one aspect. For example, silver, because when you touch upon that, silver is the most valuable part typically in a PV model, and I have not the exact numbers right now, but I know approximately around 10% of the world's silver demand are now going already towards the PV sector.
Wow.
And for that, all the people know that we really have to take care of replacing silver by other materials. So there's a lot of research going on to use copper, which has a very thin layer of silver on it, to replace this, and then trying to get rid of the silver consume. This is from the point of raw material very important. On the other hand, this is negative for the recycling, because the recycling industry, they want to have a value afterwards.
Yeah.
And if you keep out the silver, then the value for recycling is not much given anymore, because there's not much silver in, and all the other materials of the. So really, you see, the more you go into detail, you see the complexity of this recycling issue as well.
Also, complexity of manufacturing. Where do you see the manufacturing? We touched upon a bit about in Europe, and maximum part of it happens in China. What about European competitiveness in manufacturing, and where does it come? Where does it start? Where does it go?
Now, for the moment, it's very clear the manufacturing of standard PV models is done in China and some other Asian countries, but mainly dominated by Chinese companies. what we see is, of course, that the technology is not the same all the time. It develops very quickly and even more quickly in the times to come, I guess. That means we will not stay with the current technology for more than 5-10 years. Then there might become a next step of technology. What we have currently in Europe, in Japan, in US and so on, we have a lot of research going on PV. And this, of course, opens the door for new technologies to be produced again outside of China. Even so, Chinese research and industry is very well established meanwhile, and also the research in China is really great in PV. That means we will have, the best case, we might have more competition again, which is per se, I think, a very good development for the whole PV sector. And I wouldn't say it negatively in the way of competition. I see competition in a positive way, and also a lot of partnerships coming up. Because we know we have China now really as a huge industrial partner in all green technologies, and it's not only PV, it's wind, it's storage, it's hydrogen, electrolyzers, and so on and so on. We see China no more the country who replicates something, but China is really leading technology. Leading developer, and so I see really the future in partnership. And when you have recently heard a European industry, PV industry, producing the next generation of solar cells, has started a collaboration with a Chinese manufacturer. I think this is the way where in future we will develop, having partnerships, having industrial research partnerships, and working together. And coming up with new technologies side by side. We see a lot of Chinese companies producing in Europe. Meanwhile, for example, in the battery industry, I think the 4 largest battery producers in Europe are Chinese companies. And of course, if producing is done in Europe, of course, research is very close, and partnership has a good chance to be developed if it's done jointly in Europe. And of course, it's anyway, it's a global business, science, and all these developments are done only on a global level, and I see it, I hope it will be really very soon that we have a more even distribution of manufacturing worldwide. And this is of course can only be done if there is a political push. But I see, at least in some regions of the world, already this political push because of, if we had talked before about security issues, security in terms of energy sovereignty, in terms of really being aware that these crucial technologies of energy, they cannot be given just to one country. The crucial technologies, and these technologies are meanwhile the renewables. The society is relying on energy. Without them, nothing works, and we know the key technologies are meanwhile the renewables, more and more, and in the next 5 years even more. And that's why the politicians meanwhile also understood it's a question of security, to keep the technology sovereignty in the country, to keep production, manufacturing at least to a certain extent in the country, in the region. And that's why I see this diversification really coming up in the years to come.
Yeah, actually, we are recording this on 5th of May, and last week it was the International Energy Agency Forum in London, and they discussed about energy security, and they mentioned geopolitical uncertainty, but also extreme weathers, critical materials that we spoke also about it, and supply chain. So it's a huge topic now, this security. And in the same note, just to briefly comment the blackout in Spain, Portugal, and France, and what do you think about it in terms of energy security? And there are some people blaming renewable about it. What do you think?
I think what's really important to understand that we are changing our energy system. It's operated in a different way. Renewables take over, renewables have another characteristics, and of course how to operate electricity networks and how to integrate prosumers now and all that. This is quite new, and of course there are challenges behind. And of course we are used to have a very reliable, a very secure electricity system, and we want to keep that. And of course, when you have this transition, from time to time, there might happen, because of specific circumstances, there might occur some challenges. And I see this, and we know in the past years that also the development of PV, specifically the inverters, they were facing a lot of challenges. For example, how to disconnect photovoltaic from the grid in times when the main grid is switched off, for example. Yeah? They should not feed into the grid, because then they could insure some workers on the grid or something like that. So all this problem came up, but they are solved meanwhile. And of course, from time to time, some other issues might come up in this transition. But that's really about us, for the electrical engineers and for the scientific community to analyze it, to find solutions, and in the best case, to solve the problem before the big accident occurs. And I think, from time to time in this transition, something might happen. But what you have seen also again in this case of a blackout, the quality of the photovoltaic and the wind energy, that it can re-establish a grid very quickly, like hydropower can do, because of these rotating masses. And the same is now with photovoltaic. If they have grid forming inverters, really supports the grid, really forms the grid. I think this is a step which is also crucial for the future. And so this is a lot of development steps we have to go on. And I think, yes, that's the job of the engineers, to take care of this transition and to try to avoid any problems which might occur in this transition process.
Yeah, that's very important to highlight this, that power electronics can be even faster to recover from a blackout. It's good.
And actually, there was also a question that we were discussing about in Central and Eastern Europe, countries like Poland and Hungary, they can actually accelerate way faster, but just integrating PV and storage solution and not relying on the coal, and their transition could be accelerated. Yeah, I mean, because one of the concern that those countries have, that it might destabilize their grids, but as you mentioned, it's not the case.
No. It's not per se the case. Of course, you have to go into detail, but we have so many experiences meanwhile around. For example, in the International Energy Agency, since 12 years, we have a specific task working on integration of photovoltaics into the electricity networks, where more than 40-50 experts all around the world from 30 countries are coming together and really exchanging their experience and learning together and so on. So really, that's the international collaboration of scientists. And I think, all that is supporting this transition. And I think no country should start from scratch. Yeah? Even some countries might lag a little bit behind in the development of renewables, but they can really take benefit of all the knowledge which is already around and the best case practices which are around in the world. And so I see the countries lagging behind, they will quite quickly come to a similar level of renewables than the other countries, because the costs are down, at least for photovoltaics. And there is really now, it's very clear that the transition towards renewable is the most reasonable way to change our energy system, and has so many positive impacts for every society.
And do you see storage and PV going hand in hand for such countries now?
Yeah, of course. All these countries can also take big benefit of the storage development of the last years, because it was storage price went down in this nearly same way like the PV modules went down 10 years earlier. So that's really also a big benefit, that this partnership between PV and storage, which makes a huge sense, really helps a lot to integrate photovoltaic into the grid. For example, in California, there is a development of mainly home storages in the last 5, 6, 7 years. And now you see the nice graphs around where you see during the day most of solar, and in the evening, where typically there's the peak in the power supply, they came up recently in April with 37% of electricity supplied by the home storage. So really, home storage is taken over in the hours when the sun went down, and really also in the morning, some is in the storage still stored, and so you really storage really having a more and more important role in this future energy supply, which is more and more covered by photovoltaic. And of course, this is in the summertime. And what is, of course, the bigger challenge is for sure the seasonal storage. How much is used, or how much is needed for seasonal storage. I think for the summer periods, let's say in Austria, from early March to end of October, we will never face really problems, because the storage can easily solve, the battery storage can easily solve all the problems. But for example, in October, from November, December and January, we might have some issues with long-term storage, which we, I think also it's for the transition phase, it wouldn't be a big problem to use some gas turbines for a few hours a year or something like that, if it's the most cost-effective solution. But nevertheless, I'm also quite convinced that the storage solution, larger storage solutions, might be more efficient and more economic in a few years to come. And that's why I think we can replace the fossil energy in total quite quickly.
Yeah. Just we don't want to not mention your participation in DG Demo project, which is a net project. And what was it about, and what were your main lessons from it?
The DG Demo project was, let's say, the first project we started, let's say 2001 or 2002, something like that. Really to investigate how to integrate decentralized renewable into the grid. And at that time, the grid operators, mainly the distribution grid operators, they were very much hesitating on small decentralized generators to feed into their grid, because they feel feel responsible for their grid. The grid should be operated reliable in the way it was used to be worked in the years before. And of course, they couldn't really imagine at the time that 100,000 of people would feed into their grid. Yeah? There was just the consumers, and now it's the other way around. They consume and produce. Yeah. They send their electricity into the grid, and they couldn't imagine that this would work out. So you see how big the transition was and how big the resistance have been at that time. But nevertheless, we started with this DG DemoNet project, really, and leading me to the collaboration, which is so crucial. We started it really in collaboration with a handful of grid operators. Yeah, we discussed with them. We said, okay, look, this is the future. We have to deal with that. We see your responsibility. We see your challenges you have typically with operation of networks. But now the time has come really to integrate more and more renewable, and how to do it in the best way. And we really found a lot of nice solutions. We found some 3-4 demo regions in Austria, different shaped, in Vorarlberg, in Salzburg, in Upper Austria. And from that point on, we really came into touch more and more with the network operators. And we really installed first demos with a large amount of photovoltaic and other renewables, and then see how this grid works when you have such a big distribution of decentralized generation in your network. And this was the starting point. It was a project which really paved the way. And still today, I think in Vorarlberg there is one of these DG DemoNet projects in operation, the Großes Walsertal, which was worldwide, as far as I know, the first smart grid which is in operation.
So we were talking about the DG Demo project, and also we want to know about your experience in International Energy Agency. How was to collaborate with international scientific world?
Yeah, as I pointed out frequently already, I think collaboration is the key for this transition. We can learn so much from each other, and to develop something together is really great. And so I was, by the Austrian Ministry, I was invited already in 1994 to join a working group of the International Energy Agency. In that time it was about air heating solution. It has nothing to do with photovoltaic, nothing with electricity. It was just solar air heating. And I really learned to know these international energy collaborations, and I really started from the very beginning to like this way of collaborating very much, because sitting together with experts from all around the world, from 25, 30 member countries, and to develop jointly any things and to learn from each other in the way to point out best practice, discuss on recommendations for decision makers and so on. This was really very much fascinating from the very beginning. And from 2001 on, I was sent as an Austrian representative to the Photovoltaic Power Systems program. And from this time on, I really learned to know the international PV community and really see what's going on in different countries, different speeds. Some countries were much more advanced, some were very much behind. And at that time, Austria was at the very beginning, and I think we learned a lot from other countries, also from the strategic point of view. For example, we learned that it's important to have a strategic goal. We developed the first photovoltaic roadmap, I think it was in 2006, to really show what could happen if we really stick on this way towards photovoltaic. What might be the impact, what might be really the result for Austria. And so we engaged more and more in this international collaboration. And I think it's crucial to work together and to see also, and this is really again this bringing together specific aspects from the technology side to the social aspects to the political aspects, really to see the whole picture of this energy transition, of course, from the perspective of photovoltaic. And we were focusing very much on photovoltaic only until 2015-16, because we want also to support the process of bringing PV to the market. This was in the focus of the PV discussion from the beginning to, let's say, 2012, 2015, when PV really has shown that it's cost competitive. And from that moment on, we saw that the prices went down even further. It's even now on the way to be the cheapest source of electricity in many regions of the world, in many applications. And now it's really the moment really to partner with other sectors, what I've said before, with the building sector, agriculture sector, really to try to find and optimize the applications of photovoltaic. And this again in this international environment. So we have recently just established, for example, a working group on agri-photovoltaics, bringing together more than 30 countries worldwide, and even countries outside the IA, like Brazil, are also participating in this international working group. And we have one colleague who really is the Austrian representative there and brings back all this information from outside to Austria. And of course, in the other way around, we have also some experience in Austria meanwhile, and we want also to bring our experience to this international group. And this exchange, and this is of course connected with a lot of personal relationships meanwhile. So after this more than 20 years, I really can say, and it's, let's say on the personal level, one of my best friends meanwhile are friends I have learned to know in the IA environment. Like one of my best friends is Australian, another good friend is from France, and so on. So really, this is really very nice to see how this global network works. And the more you also have this personal relations established, the more easy it is to get in touch when you want to really know what's going on in Japan, in Australia, in Malaysia, and so on. And it's very easy to just send an email to your friend, more or less, and really see what's going on. And this is the relation you have in this group. of course, it's necessary to stay there for longer. So if you send just an expert for one meeting, it doesn't help a lot. But if you stay really for a long time, you really can establish really very good personnel expert networks, and by that really taking benefit. And we try to bring all this benefit out of the IEA working program towards the Austrian community, mainly by the Austrian PV Technology Platform, where we have together the whole Austrian community. And so we really have this exchange between the international community and the Austrian community. And so this really gives really a good impetus for Austrian developments to bring PV forward.
Cool. And just a small note that you mentioned that you developed the roadmap back in 2006. How it evolved in time? Was it addressed? Was it similar to the roadmap? What actually happened?
Yes, it was not so far away because I was criticized quite a lot that already at the time I wrote that PV really will have a bright future, a very bright future. And a lot of people really didn't believe in that and said, you are much more too enthusiastic and this doesn't make sense, and they want to reduce the numbers which I wanted to introduce in this roadmap. But finally, if you have a look to this roadmap from 2006, you will see I was already at that time talking about 15% of the electricity from PV. At that time we were at 0.1 or something like that. And now the reality is even a little bit faster than my assumption, but basically we are quite in line.
Okay, amazing.
And is it similar in adoption? You created the framework for Austria, but for like broader eastern region as well. Are there similarities between their roadmap that is going on? Or what is hindering their growth?
Yeah, the roadmaps were developed in some countries, not too many, because it's just a strategic document, really to show what is the potential of this technology, what needs to be done also on the political arena, on the support schemes in order to bring up this technology, what has to be taken into account aside, and what of course is the benefit for the industry and why we should move towards this development. And of course, finally, what is needed and what is crucial is the political support. Yeah. Because at least in the beginning of this technology, it was needed really to support, because it was by far not competitive. It was much too expensive compared to the other energy sources. Because nobody cared at that time about CO2, nobody cared about the emissions of fossil energy and so on. And so photovoltaic was not competitive at all, like all the other renewables. Of course, by and by, the political systems have changed a little bit by introduction of CO2 taxes and some other regulations, and of course promoting renewables a lot. And now, of course, yes, by step, also the industry has seen a value of this technology, and latest at the point when PV was somehow competitive, then really this was a big jump forward, because then all the other people say, okay, this is now really a cost benefit for me if I invest into PV system, and it's not only a cost benefit for the moment. It's also, let's say, a benefit for the future to really have energy costs which are calculable. Yes, because you're not so much dependent anymore on international price developments of gas or oil or something like that. And if you have, let's say, 30, 40, 50% of your electricity provided from your own system, then you're less dependent than you are completely dependent on international markets. And so this is also a factor which more and more was attractive for the industry to come up with own energy supply as far as possible by PV, now added much more by PV storage systems, and maybe they have only a contract, a PPA or something with wind or something like that, then they might be capable of covering more or less the whole energy they need from renewables.
Yeah, we have talked also in other interviews about energy independence. So it's very related. And now with all your experience in Austria sector, what would you like to be your main contribution to the PV sector in Austria, Europe, the world.
I have a
Absolutely.
question
Yes.
to add to it as well, because you spend a lot of time educating people about PV energy as a whole as well. What do you think that students coming along who want to work in the sector, what skill jobs that are coming, what they should focus on, what is going to be making them find a job of the future in this industry?
I think the most important prerequisite for students in this field is to be somehow enthusiastic and really want to move on and bring forward something. As soon as they step in the technology and the whole development, most of them automatically became fascinated of this technology, because not of the technology PV as such, but of the renewables, because wind technology and all the other technologies around are also fascinating, because it's really this great transition the society has in front of us. And as soon as you're really enthusiastic, you find a lot of jobs, because it's mainly the personal motivation which drives you to be engaged. And if you see you make something which is reasonable, you can move on, you can bring up something and move forward. I think this is, of course, really a job which is great. And yeah, I have worked a lot of years and days and hours for the renewable sector, but I don't remember any hour which was boring so far, because it was really exciting from the very first moment. And I think
you keep feeling the same feeling.
Yeah, and it's nice that if this can be transferred to somebody else, it would be, of course, very nice that you can see you can also motivate other people to jointly work on this big job, because there is still a lot to do. We are far away from reaching our goal. We have still in Austria about 60% of fossil energy in the whole energy sector, worldwide even more. So it's a huge future effort which has to be made by the next generation, let's say like that. And yeah, I think it's a great job, and it's a great thing to do. And what is now really different than before is that most of the people really now believe that this is the only way we have to do. They only think the only way forward is the way towards renewable. It was not so 20 years ago, but I think now it's quite clear that this is a need for the society to move on in this direction. And all the alternatives which are around really are more and more collapsing more and more.
Yeah, that's it. I don't know, do you have something else to add?
No, just in the question that Daniel asked, your legacy, you have been working for 30 years, you still have the passion that we see, which we can also light something up in ourselves. But what legacy you want to leave? What about PV next? Any closing argument that you have?
Any closing argument?
Yeah, about your passion, what is still driving you? Like, are you expecting something more to happen? What's making you still drive with the passion that you have?
Now, what I like really very much in the last only few years, 3-4 years, it's that we were so many years talking about renewables. We were so many years making research in renewables, but now we are really starting to implement them. And then you see really the people on the countryside, the people in the urban areas, really all the people, they are really now working in the sector. They are really using renewables with all the applications around, with all the new topics which come up with the intensive use of renewables. And this is really fascinating to see a long period of time of research and theoretical things. And now we put that into the practice. And this is really great to follow this. And I am involved currently in 3 regional projects. They have all the targets to have 35 already 100% of renewable energy. And this is really great to see how the people have the ambition to realize the target in time. And to see now really PV systems and other renewable energy systems, grids, and all that coming up, and really seeing how the energy transition is really put into practice. This is really fascinating now.
And what do you think is the next step in the technology wise, like the next big challenge that we are going to face in the industry?
And from production wise or from user side? What do you mean?
I think in user it will be more
User side. Yeah, for the industry, I think industry wants to have a clear and good frame condition for the future, for long-term prospects. And I think if they can rely on energy, which comes from renewable, and their customers also are questioning more and more, how do you produce, what resources, what energy. I think the more comes into mind that we have to move, and this is the big step beyond all that is, of course, the circular economy, because when we talk about renewable energy, it's just one part of a circular economy.
Nice.
Because the big thing what we have to talk about is to close the loops. Yeah? We have restricted resources, limited resources, and we have not only in energy but also in the all materials. We have to try to use that in the most responsible way, to use it most effectively, and after the usage we have to try to bring that back in the circle as much as possible. Otherwise we cannot maintain to have more than 8 billion people on this planet, and this would not work on. So I think, yeah, really bringing to the people to the mindsets that basically it's all about the circular economy. I think this is one of the most crucial points.
Amazing final words, I think, to finish the interview. The circular economy also drive us to do this. We're very grateful for having you here. As Raúl mentioned, your passion also inspired us to start this project. And my outgoing thought from the interview, it's the importance of collaboration, as you mentioned. And it's something that we want to address too with Energy Bridge, to put together academia, industry, policymakers, and also innovation. So thank you very much, Professor.
Thank you, Professor. It's been an honor, and thank you for doing what you do, and thank you for coming and giving us this very insightful interview. Thank you.
Thank you very much for inviting me, and really congratulations what you're doing.
Okay.
Thank you very much.
Amazing.
Thank you.
And keep in touch in the community for the next episodes, and see you next time. Ciao.